All right, in this video we're going to look at eliminating the xy term in a rotated conic section. So in our last video we looked at graphing an entire function that had, it was an ellipse that was rotated a bit, and given an equation in the form ax squared plus bxy plus cy squared plus dx plus ef, or plus ey plus f equals 0 rather, where this value of b is not equal to 0. When b is not equal to 0, that's going to cause our original graph to rotate. So this xy term that we have in our equation causes our conic section to rotate. So if there is a non-zero coefficient, there is an xy term, then there actually exists an angle that if we rotated the equation counterclockwise by that angle, our bxy term would be eliminated. So for instance, looking at our example we did in the last video, our original graph was this one in black, and then the one in red was the equation with x prime, y prime. Now I can't use x prime, y prime here for this, but you get the idea. And what we're going to look at today is being able to determine, let's say we took the top of this ellipse here and the top of this ellipse here. If we rotated our graph this many radians or this many degrees, it would essentially eliminate this xy term, this 10xy squared root of 3 term, and we would have our ellipse like we have right here with the x squared over 4 plus y squared over 9 equals 1. So in order to do that, if we substitute x prime cosine theta minus y prime sine theta for x in our equation, and we substitute x prime sine theta plus y prime cosine theta in for y, we're going to get the following for our ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So substituting this in for the x's and this in for the y's, there's a lot of algebra involved here. So squaring this and multiplying these out, and again, if you are up for the challenge, multiply all this out, combine your like terms. You'll probably have some sine squareds plus cosine squareds, going to simplify to ones maybe. But doing the algebra for it, and trust me, this is what you get for your coefficient for x prime, y prime. So you get 2 times c minus a times the sine of theta cosine theta plus b times cosine squared theta minus sine squared theta as our coefficient for the x prime, y prime. So a lot of algebra involved, but this is eventually what you'll get. Now 2 times sine theta times cosine theta is our double angle sine identity, and cosine squared theta minus sine squared theta is our double angle cosine identity. At least it's one of the 3 versions of the double angle cosine identity. So c minus a times 2 times sine times cosine is double angle sine, so it's sine of 2 theta, and cosine squared minus sine squared again is cosine of 2 theta. So we have b plus cosine of 2 theta. And if we set it equal to 0, because again we want this coefficient for x prime, y prime to go away, so if we set this expression equal to 0, we'll get a minus c times the sine of 2 theta equals b times the cosine of 2 theta. So just bringing this over and switching it around from c minus a to a minus c. Again, if you distribute the sine 2 theta and bring all the terms over and factor out the sine 2 theta again, you'll get a minus c times the sine of 2 theta equals b times the cosine of 2 theta. And from there, if we divide both sides by b and divide both sides by sine 2 theta, we get cotangent of 2 theta. Cosine of 2 theta over sine of 2 theta is cotangent of 2 theta equals a minus c over b. And from there, that could give us our angle once we solve for theta and know how much we have to rotate in order to get rid of our xy term. So example 2, find the smallest angle of rotation in order to rewrite each of these without having an xy term. So to be able to rewrite this without having this xy term and get it rotated to the point where we can either have it going either up, down, or left, right for our various conic sections, I guess. So looking at what we have here, we have A is 5, B is 26, and C is 5. So cotangent of 2 theta is 5 minus 5 over 26. Cotangent of 2 theta is 0. So 2 theta is the inverse cotangent of 0, which is 90 degrees, and then divide both sides by 2. So if we rotate it 45 degrees or pi over 4 radians counterclockwise, or clockwise rather, pardon me. If we rotate this equation, this graph of this equation, pi over 4 radians clockwise, we will get a graph that is not rotated. Part B, we have 16x squared plus 24xy plus 9y squared plus 15x minus 20y equals 0. So here we have A is 16, B is 24, and C is 9. So 16 minus 9 divided by 24 is cotangent of 2 theta. Pardon me. Means cotangent of 2 theta is 7/24. So 2 theta is the inverse cotangent of 7/24, which is about 73.8 degrees. And if we divide both sides by 2, we get about 36.9 degrees to rotate it back, where it is no longer at an angle in the xy coordinate plane. So about 37 degrees roughly for example 2b. All right, that about does it in this video. In the next one, we're going to look at identifying what kind of conic it is based on its equation, even if it's rotated in the coordinate plane. So I'll see you then.